All right, get ready because today we're taking a deep dive into some really fascinating AI research.
Yeah, it's pretty mind-bending stuff.
Imagine an AI research assistant that can not only, you know, understand tons of text, but also make sense of complex diagrams and images.
Right, like looking at a diagram and actually understanding what it represents.
Exactly. And get this, it can then use all that information to help you solve problems and make smarter decisions.
And it's not just limited to one specific type of problem either. We're talking about a more general approach to AI reasoning.
That's the potential we're exploring today with a new framework called ARMCTS.
It stands for Augmented Retrieval Monte Carlo Tree Search.
Catchy, right?
Yeah, it's a mouthful, but it really captures the essence of what this research is all about.
So what makes this research so groundbreaking?
Well, it's not just about making AI better at, say, solving math problems or passing a Chinese exam, although it does that too.
Right. The paper uses those as benchmarks.
It's about figuring out how AI can learn more like we do using textbooks, notes, and outside resources, not just relying on its own internal memory.
Okay, I like that. Give AI the ability to study for an open book exam.
That's a great way to put it.
But, before we get ahead of ourselves, let's talk about why this is such a big deal.
Sure.
We've all heard about these large language models, these LLMs, but
Right, like ChatGPT and all those.
yeah, exactly. They still struggle with multi-step reasoning.
Especially when you throw images into the mix.
Right. It's like they can understand individual words and pictures, but putting it all together to, let's say, interpret a medical scan or solve a geometry problem with a diagram,
That's where they hit a wall.
they just kind of fall apart.
Exactly.
So how is ARMCTS trying to break through that wall?
Well, to help understand that, the paper uses this really interesting analogy, this Choose Your Own Adventure book analogy,
Oh, yeah, I remember those books.
to explain the challenge of multi-step reasoning.
Yeah, can you walk me through that a little bit?
Sure. Imagine you're reading one of those books where each decision you make leads you down a different path.
Right, so every choice has consequences.
Exactly.
And it kind of changes the story.
Yeah, and with every choice, the story branches out, creating this giant tree of possibilities.
Like a decision tree.
Exactly like a decision tree. And for an AI solving a multi-step problem, it's facing a similar challenge.
Because, with each step, there are multiple options.
Right. Each decision it makes opens up a whole new set of potential solutions.
And it has to figure out which one is the best.
And it needs a way to navigate this complex web of choices efficiently.
Okay, so it's not just about finding the right answer, it's about figuring out the best path to get there, right?
Precisely.
And that's where Monte Carlo tree search, or MCTS, comes
Yes,
in.
right on.
I've heard that term before, but never really understood what it means.
So MCTS is a classic technique for exploring these huge decision trees without getting lost in the weeds.
Without going down every single path.
Right. It's a way for the AI to strategically sample different paths and focus its energy on the most promising ones.
Okay, so MCTS helps the AI navigate the choose your own adventure efficiently.
Yeah.
But even with that, these multimodal LLMs, or MLLMs for short.
Right. MLLMs, because we're dealing with multiple modalities like text and images,
Yeah.
they still need a little something extra to really excel.
Right, it's like they have the potential.
So they have all these potential paths laid out.
But they don't know which one to take.
They might not know which one to take. They have the map, but they might be missing the compass.
Okay, I like that analogy.
And that's where the active retrieval part of ARMCTS comes into play.
Okay, so this is the AR part.
Exactly, the augmented retrieval.
So what is that? Like, how does that work?
Think of it as giving the AI the ability to access a vast library of knowledge at each step of the problem-solving process.
So it's not just looking at the decision tree, it's also looking at all this other information.
Right, it can consult a guidebook, look at some photos, maybe even ask a local for directions, so to speak.
Okay, so instead of just like staring at the map, it
Exactly.
can actually look at other things.
It can access additional information that might be helpful.
And what is this library? Is it like a specific database or something?
Yeah, this library is what we call a hybrid modal corpus.
Hybrid modal,
Hybrid because it includes both text and multimodal sources.
like images with descriptions.
Exactly, like images paired with descriptions. And it's a carefully curated collection of information, including things like Wikipedia articles,
So like general knowledge.
general knowledge, scientific papers with diagrams,
So more specialized information as well.
more specialized information, even competition problems with solutions.
Wow, so they're really giving this AI a lot to work with.
Yeah, they're trying to provide it with a rich and diverse knowledge base to draw from.
So it's not just about having access to a ton of information. It's about knowing how to use it strategically.
That's a key point. It's not just about quantity, it's about quality and relevance.
The paper mentions something called knowledge concept filtering. Is
Yeah.
that what you're talking about?
Yes,
It's
exactly.
like the AI is trying to match the type of knowledge it needs to the specific problem it's facing.
Right. It's like if the problem's about geometry,
It's going to look for geometry stuff.
the AI will prioritize retrieving geometry-related information from the corpus. If it's a medical diagnosis,
Medical textbooks.
it'll focus on medical textbooks and research, not, say, the history of art.
Okay, so it's not just randomly grabbing information.
No, it's being selective. And this helps to improve accuracy and efficiency by reducing noise and distractions.
Okay, that makes sense. So by filtering the information, the AI can quickly zero in on the most relevant knowledge.
Right, and that saves time and computational power.
So it's like giving the AI a set of mental tools.
And teaching it which tool to use for which job.
Okay, I'm starting to get the big picture here. It's really interesting how they're trying to make this AI more human-like in its reasoning.
Yeah, the goal is to create AI that can think more critically and strategically, just like we do.
And use external resources to its advantage.
Exactly, just like a student would use a textbook, or a researcher would consult a database.
This is really fascinating stuff. I'm excited to dive deeper into the specifics of how this all works in practice.
Me too. There's a lot more to explore here, from the training process to the actual results they achieved.
All right, well, let's take a quick break, and when we come back, we'll delve into those details and see how AR-MCTS actually performs in the real world.
Sounds good to me. It really is remarkable to see how this AI is almost thinking out loud as it explores different paths.
Yeah, like it's actually considering different options.
Right, and one of the things that struck me in the paper was this concept of a sampling space, which you described earlier as brainstorming.
Oh, yeah, that's where the AI explores a whole bunch of different solution paths.
Exactly. So what are some of the benefits of having a more diverse sampling space?
Well, I guess for starters, it's like having a backup plan or even multiple backup plans.
Right, so if one approach doesn't work out,
Yeah, if one approach doesn't work out, the AI can just switch gears and try different tactics.
it makes the AI more resilient and less likely to get stuck.
It's kind of like how a good chess player thinks ahead, right?
That's a great analogy. And another benefit is that this diverse exploration can lead to more creative and innovative solutions.
It's almost like the AI is brainstorming with itself.
Yeah, considering approaches that humans might overlook.
It's like those times when you're stuck on a problem and then suddenly a fresh perspective just pops into your head.
Exactly. And this diversity of thought also helps to reduce bias.
Oh, how so?
Well, if the AI is only considering a narrow range of possibilities, it might be more likely to reflect the biases present in its training data.
So it might make biased decisions.
Yeah, but by exploring a wider range of perspectives, the AI can potentially arrive at a more objective and unbiased solution.
Okay, that's really important, especially as AI becomes more prevalent in sensitive areas like healthcare, finance, legal decisions.
Absolutely. We need these systems to be as fair and impartial as possible.
We don't want biased AI making decisions that affect people's lives.
Exactly. And this research is showing us that it's possible to design AI systems that not only solve problems effectively, but also do so in a way that is more transparent and less prone to bias.
So we're not just building AI that's smart, we're building AI that's also ethical and fair.
Right. It's like building guardrails into the AI's thinking process to ensure that it's operating in a way that aligns with our values.
Okay, that's good to hear.
It's all about responsible AI development.
So we've talked about how AR-MCTS works, its benefits, but
Yeah.
are there any downsides?
Of course, no AI system is perfect. One limitation of AR-MCPS is that it can be computationally expensive.
Oh, that makes sense.
Remember, this AI is constantly accessing and processing information from its external knowledge base.
Which takes a lot of computing power.
Exactly, especially for complex problems.
So it might take longer to run.
It could be a challenge for applications that require real-time decision-making, where speed is critical.
Yeah, I can see that being an issue.
And another potential challenge is ensuring the quality and reliability of the information in the AI's corpus.
Oh, right, because it's getting information from outside.
Remember, this external knowledge base is like the AI's textbook.
And textbooks can be wrong sometimes.
And just like any textbook, it could contain errors or outdated information.
So it's like, what if the AI accidentally learns from a website with fake news?
Exactly. And if the AI isn't able to discern between reliable and unreliable information, that could lead to problems.
Faulty reasoning.
Incorrect conclusions.
It seems like there's a delicate balance between giving the AI access to a vast knowledge base and making sure that the information it's using is accurate and trustworthy.
Right. It's like walking a tightrope.
So how did the researchers address that challenge?
They've been very careful to ensure that the AI isn't cheating,
Cheat.
like peeking at the test answers. They've curated and vetted the corpus to ensure quality and relevance.
So they've made sure that the information in the corpus is accurate and up to date.
Exactly. And they've taken steps to prevent the AI from simply memorizing solutions to specific problems.
So they're teaching it to actually understand the concepts, not just memorize answers.
Precisely. It's all about teaching the AI to generalize its knowledge and apply it to new and unseen challenges.
Okay, that's reassuring to hear.
It's all part of making sure the AI is learning effectively.
Now, the research paper mentioned that AR-MCTS is particularly effective at boosting the performance of smaller AI models.
Yes, that's one of the interesting findings.
Why is that?
Well, smaller models often have limited internal knowledge and processing power compared to their larger counterparts.
So they have less to work with.
It's like they have a smaller toolbox and fewer mental resources.
They need a little extra help.
And that's where AR-MCTS shines. By providing these smaller models with a more efficient way to access and process relevant information, we can significantly enhance their reasoning abilities.
So AR-MCTS helps level the playing field, allowing even those AI models that might not be the biggest or most powerful to achieve impressive results.
Precisely. It's like giving them a boost.
That's really interesting.
And has the potential to democratize AI, making these advanced capabilities accessible to researchers and developers who might not have access to the biggest and most expensive models.
Okay, I like that. More access for everyone.
Exactly. It's about making AI more inclusive.
I'm curious about the benchmarks that were used to evaluate AR-MCTS. The paper mentioned MathVista and WeMath.
Oh yeah, those are some tough benchmarks.
What can you tell me about those?
Well, these benchmarks are like specialized tests designed to assess the AI's mathematical reasoning skills.
So how good is the AI at math?
Right, and they're particularly focused on situations where the AI needs to process both text and images.
So it's not just about solving equations, it's about understanding the concepts.
Exactly. MathVista, for example, presents a variety of math problems across different areas, like geometry, algebra, and even statistics.
So it's a pretty comprehensive test.
It is. And WeMath is another tough one. It focuses on multi-step reasoning, testing the AI's ability to break down complex problems into smaller steps, think logically, and arrive at the correct solution.
So it's testing the AI's strategic thinking and problem-solving skills?
Exactly. It's like a real-world problem-solving scenario.
Did AR-MCTS perform well on these benchmarks?
Yes, it did. It consistently outperformed other approaches on both MathVista and WeMath,
So it's proving its worth.
showing that it can significantly enhance the reasoning capabilities of MLLMs.
Okay, that's impressive.
And the fact that it performs well across different types of problems and models suggests that the underlying principles are quite robust and adaptable.
So it's not just a one-trick pony.
Right. It has the potential to be applied to a wide range of AI applications.
This has been such an enlightening conversation. I feel like I've gained a much deeper understanding of how AR-MCTS works and its potential impact.
I'm glad to hear that.
Before we move on, is there anything else about this research that you found particularly noteworthy?
Yes, I was particularly intrigued by the training process for the process reward model, or PRM.
Oh, that's the AI's internal coach, right?
Exactly. And they used a two-stage training approach that I think is worth exploring further.
Yeah, we touched on it briefly earlier, but I'd love to dive a bit deeper into those two stages.
Sure, let's do that.
What exactly happens during each stage?
Okay, so in the first stage, they use a technique called direct preference optimization, or DPO.
DPO. Okay.
Essentially, they present the PRM with pairs of reasoning steps, one good, one bad, and train it to assign a higher score to the good step.
So it's like showing the AI coach examples of good and bad moves and saying, this is good, this is bad.
Exactly. And through repeated exposure to these examples, the PRM begins to develop a sense of what constitutes a good reasoning step versus a bad one.
Okay, so it's learning by example.
Right. But it's not just about memorizing those specific examples.
It's actually learning the underlying principles.
Exactly. And that's where the second stage of training comes in.
SFT, all right?
Where they provide the PRM with more detailed feedback, not just a good or bad label, but a score reflecting the quality of the reasoning step.
So it's like giving the AI coach more nuanced feedback.
Exactly. It's like saying, that was a good move, but you could have improved it by.
So it's getting more specific guidance.
Right, and this fine-tuning process is crucial because it allows the PRM to develop a much more sophisticated understanding of reasoning and to provide more precise feedback to the AI during the problem-solving process.
It's like they're training the AI to not only follow the rules, but also to develop a deep understanding of the strategy.
Exactly, and that leads to more effective problem-solving.
This has been such an insightful deep dive so far. We've explored the inner workings of AR-MCTS, its strengths and limitations, and even how the AI is trained to reason effectively.
Yeah, we've covered a lot of ground.
Now, I'm curious to shift our focus to the bigger picture.
The big picture, okay.
What are the broader implications of this research for the future of AI? Where could this lead?
You know, it's crazy to think we've only just started to see what AR-MCTS can do.
Oh, yeah. We're just scratching the surface here.
This research is all about math problems and a Chinese exam, but
Right, those are just benchmarks they used.
where else could we use this? What other fields could benefit?
The possibilities are pretty much endless. This research gives us a glimpse of AI that's not just a tool,
But like a real partner.
a partner in problem solving. Imagine AI working with scientists, doctors, engineers, even artists,
Wow, that's a lot.
helping them to be even more creative and innovative.
It's like having an AI teammate.
Yeah. One that can process information super fast, but also understands how we talk, interprets visual data, and comes up with ideas we might not have thought of.
Exactly. And the fact that it's multimodal, handling both text and images, that's what makes it so powerful.
Because the real world isn't just words or pictures.
Right, it's a mix of everything.
It's like how architects work, you know?
Oh yeah, they're constantly looking at blueprints, visualizing spaces, thinking about materials, all at the same time.
Could AR MCTS be used to make AI that can do that kind of design work?
Absolutely. Imagine an AI that can analyze building plans, simulate whether a structure will hold up, even suggest design improvements.
That would change everything about how we design and build things.
It would revolutionize architecture and engineering.
And what about scientific research?
Oh, that's another huge area where this could have a major impact.
An AI that can read tons of research papers, understand the data, even figure out those complicated graphs and charts?
It could help scientists make discoveries way faster than we can now.
It would be like having an army of research assistants, all working 24/7.
Exactly. Helping scientists connect the dots and find hidden patterns in the data.
Okay, this is all very exciting.
It is,
But how do we go from solving math problems to, curing diseases or designing eco-friendly cities?
it's a big jump, for sure. But that's how research works.
Start small and then
Yeah, this is early stage work showing us what's possible.
proof of concept.
The key is that the ideas behind ARMCTS, using outside knowledge, rewarding good reasoning, encouraging exploration,
Those can be applied to all sorts of problems.
to a wide range of challenges.
It's like we've found a new recipe, and now it's up to chefs to create amazing dishes with it.
I love that analogy.
Okay.
And that's where the real excitement lies.
So researchers in different fields can take these ideas and run with them.
Climate science, medicine, education,
AI powered by AR-MCTS helping doctors, engineers.
AI tutors that actually understand how each student learns best.
Wow, this is getting me really optimistic. But okay, let's be real for a second.
Right,
What
yeah.
are some challenges we need to think about as this technology keeps developing?
Well, we already talked about how much computing power it takes and how important it is to have good data.
Yeah, what else?
We need to make sure these AI systems are understandable and trustworthy.
That makes sense.
Even if an AI has a great suggestion, if we don't know how it got there,
It's hard to trust it.
exactly,
Yeah.
we need to be able to see inside, understand its thought process.
It's like how you've been explaining all this AI stuff to me.
Oh yeah,
You're not just giving me the answers.
I'm trying to help you understand the why.
Yeah, and that's what we need from AI.
Transparency.
Explainability.
So we know why it's making the decisions it's making.
Especially if it's like a medical diagnosis or something.
Right, high-stakes decisions.
We can't just blindly trust it,
We need to build a partnership with AI based on understanding and trust.
not just faith.
And that's where human expertise is still so important.
So it's not about AI replacing us.
It's about AI working with us.
Helping us to see things we might have missed, make better decisions.
It's about collaboration, not competition.
This has been an amazing deep dive.
I've really enjoyed this conversation.
I feel like I've learned so much about AR-MCTS and what it means for the future.
Me too. It's exciting to think about where this research might lead.
If you could give one piece of advice to someone working on this kind of AI, what would it be?
I would say Remember that AI is a tool,
right?
and like any tool, it can be used for good or bad.
It depends on how we use it.
As you develop these powerful systems, think about how they'll impact people's lives. Think about the ethical implications, potential biases, unintended consequences.
We have to be careful.
Strive to build AI that makes us better, not worse.
That's such important advice.
It's about using AI to create a better future for everyone.
Well said. And on that note, I think we've reached the end of our deep dive into AR-MCTS.
Wow, time flies when you're having fun talking about AI.
Listeners, we want to hear your thoughts. What did you learn? What excites you? What worries you?
Share your thoughts on our website or social media.
And if this has made you curious,
Check out the research paper itself. We'll have links in the show notes.
there's always more to learn, and that's what makes this field so fascinating.
It's a constantly evolving landscape.
Until next time, keep exploring, keep questioning, and keep diving deeper.
And keep learning.